Proof of Euler's formula without Taylor series. Okay, so today I'm going to prove Euler's formula that e to the I theta is equal to the cosine of theta plus I times the sine of theta. And I'm going to do it in a non-traditional way. I've seen many proofs where people expand e to the x using a Taylor series approximation and then rearrange the infinite sum to prove that it is equal to the cosine of theta plus I times the sine of theta. Instead of doing that, I'm going to set the cosine of theta plus I times the sine of theta equal to some complex function z. So we're going to let z equal cosine of theta plus I times the sine of theta. Then I'm going to solve for dz over d theta, or the first derivative of z, which is equal to the negative sine of theta plus I times the cosine of theta. If we rearrange that, we put I times the cosine of theta, and instead of writing minus sine times theta, I'm going to write that negative 1 as I squared, since I squared is equal to negative 1. Then I'll factor out the I from both terms, and we'll have cosine of theta plus I times the sine of theta. Now this is actually our z right here. So I have just proved that dz over d theta is equal to I times z. This is very useful because we can now rearrange it so that we have dz over z is equal to I d theta. With this, we can integrate both sides. The integral of 1 over z with respect to z will be the natural logarithm of z, which will be equal to I as a constant times theta plus the constant c. Next, we exponentiate both sides, leaving us with z equal to e to the I theta plus c. We can rewrite c as e to the c, or just a constant times e to the I theta. Now we can prove that this constant is equal to 1 by substituting theta equals 0 into z. If we substitute theta equals 0, we get cosine of 0, which is equal to 1, plus I times the sine of 0, which is equal to 0. That means z equals 1, and e to the I theta will also be equal to 1. This implies that our constant c is equal to 1. Thus, we have proven that z is equal to e to the I theta. Since we know that z is equal to cosine of theta plus I sine theta, we conclude that e to the I theta is equal to cosine of theta plus I times the sine of theta. And we're done. And that concludes our proof of Euler's formula without using a Taylor series. I hope you found this approach insightful. Thanks for watching.